So today's topic is the Indian Air India Flight 171 crashed about a week ago. There has been so much online, and this is something I have interest in. So I feel compelled to add to this. I'm sorry for this um, very rudimentary and um, silly below basic video. Um, in fact, it's the new channel today and my first video. Did I say that already? So it's really probably the most extraordinary crash that I have come across in my research on this topic. Again, I think this is so big that it compelled me to make my first ever video, to load my first YouTube video ever on any topic. So, well, how should I start? I mean, it's really, the 787 is a very, it's a big jet. It's a wide body jet, and I think it can take, over 300 people. So the basic, I'm sure that you guys have heard on other news and from other sources. So a quick rundown: 787 is probably Boeing's latest production commercial airplane, which is called wide body, which means it's basically fat with two aisles. Takes a lot of people. The significance of this is that it's the first Boeing essentially all carbon fiber composite airplane, the fuselage, the wings, everything. Fly-by-wire. It has a lot of innovations, and including more comfortable cabin with a cabin pressure altitude 6,000 feet as opposed to traditional 8,000 feet. 2,000 feet below makes life a lot more comfortable. And I don't know if they have high humidity control. They pump humidity into that too. I don't know. The windows are larger because the materials they make has a better strength to weight, so they can cut out large opening and be able to still have the same strength to fly. There are lots of innovations, both in terms of the flight capabilities, for characteristics, the efficiencies, passenger comforts, and all that. I don't know exactly all the details because I was not in the project. How Boeing executed related to the recent quality control, that I have no first-hand knowledge of it. Anyway, I don't believe that this is I would say a primary quality control problem. Anyway, I diverge. Again, where should I start? Well, this is a very curious and also potentially serious. So I would say, as first, I would start the story as a whole, as opposed to other people who present the story with a separation between the pilot, the airplane, the airline, the manufacturer, the flight conditions, or whatever. I would say that I would group the airplane and the pilot as a single entity at first. So what happens, if you can see, the airplane, and also there's if you would hold on, I have some information that I feel is previously not mentioned by anybody. Again, at this stage, we don't have all the informations, and most of it is speculation or observation, or speculation based on observation. But I think even before I start with all of that, like many people, I have a lot of questions. For example, why is that the flight recorder the black boxes, which is the flight data recorder and the cockpit voice recorder being recovered? I don't know how long it takes to read those things, But why is that there is not a standard or law or some practice to release those data to the public as soon as possible? I mean, after all, those people pay for the ticket, they had expectations, and at least the customers and the family should have instant access. And I'm not going to, accuse of anything, but, this shouldn't be a secret. It shouldn't take years, whatever. People should be able to, grounded those data are probably in codes, and an ordinary person would not, know how to interpret it. But I think, the public died. So shouldn't, they just died. And why should they wait up to years to access those data? And who is to authenticate those data, right? Data can be generated within seconds, especially with AI. So the authenticity of that, so, again, this is going to be one of those things, I think, in many areas, if people are, really interested in improved flight safety and justice, this is one crash that might potentially have a huge, dramatic impact or change to the entire commercial airline industry. Anyway, go back to the original topic. Is So what you see is that this airplane, it took off, and you can see when it took off, there's a lot of, when it rotate, means that the tail, the nose tilted up, the tail goes down, and so that's what they call rotation. And you can see there's a lot of dust got kicked up, not just by the engines. It's actually, a lot of people don't realize is that why airplanes fly. There's a little extra aeronautical information there. It's because the wings push air down, in the simplest form, and so the airplane, as an opposite reaction, go up. So there is the airplane. These kind of airplanes weigh what, 300, actually probably what, 400, 500, 600,000 pounds. 200 and 300 tons. I mean, that's a huge amount of weight. So when it rotates, it presents an angle, quite a high angle to where it's traveling. So whilst it's on the runway straight into the direction it's traveling, the wings are not deflecting a lot of air down. But once it pushes the nose up, that's at takeoff speed, suddenly the airplane presented itself at a high angle to the oncoming air, so it deflects a huge amount. I mean, that's the equivalent to, literally hundreds of tons of force that comes out of deflecting air down. And you can see the swirl, and of course the engine is also at high power setting, and so the dust, and you can see that the swirls on the wingtip. So both the wings and the engines are producing very healthy amounts of forces to get the airplane out of the ground. And you can see, actually, the airplane lifts off as a very, very positive climb angle and also climb rate, which means how many feet it climbs in a second. But soon after, the airplane slow down the climb rate, and it begins to I don't know whether you want to use the word fall, but it has a sink. It becomes a sink. Now, obviously, people have observed both visually and audially that the so-called ram air turbine that Red has deployed, and so on other channels it's been well explained under what conditions these things, such a thing is deployed, specifically on 787 from pilots who flew them. But basically, there is no other source of electrical power to power the things the airplane need to fly, the controls and stuff like that, and they are driven by the engines. And the 787, I believe, has a generator on both of the engines, not traditionally just one of the two engines. and because it's an airplane that uses so-called fly-by-wire and a lot of other advanced electrical systems that replace hydraulic, and so the airplane uses a huge amount of electricity and generates a huge amount of electricity from these two the generations on these engines compared to traditional airplanes, if I'm correct. And so um, uh, so basically, as you can see, it is very likely that both engines have failed, meaning that they are not broken, but they definitely are not spinning, operating in such a way that spinning fast enough or fuel going through. They're not producing any thrust, i.e., the the propulsion force that needed to climb, and it's very unlikely that the engine themselves, just one of them fail is unlikely. Both of them fail at the same time because of the engine themselves. It's almost impossible. So it's something that common to both engines that make them that control them or feed them, that make them run, that failed. That is with a high degree of I would say reliability. That's what happened. What it is, we don't know, because I'm not the expert of this particular type of airplane. But and as far as the flaps, if you look at carefully, you will see that actually there is a little bit of flaps, probably takeoff flaps, um, uh, that was set. So the flaps, I think, is fine, and especially the flaps were not retracting while it was going up. As you can see, the same amount of flaps was when it's rotate and when it was sinking. So the pilots didn't start to retract the flaps, and you can see when it rotated, it climbed very healthily. Actually, modern days jets is amazing. It's an amazing thing to see these huge airplanes. They look like lumbering, giants, but if you really measure in miles an hour or number of feet per second it climbs, it's actually quite an amazing thing. And so you can see that because the airplane is symmetric when it is straight, both in terms of which way it tilts and the direction it's going, and everything is straight, and so there's no asymmetry when the engines fail. So it's safe to assume both engines lost thrust at the same time, and you can also see there's no visible amount of rudder deflection to keep it straight. So there's no asymmetrical thrust or asymmetrical propulsion there. But the other things I think some of the people on the YouTube channel fail to mention is that if you look carefully, the tailplane, the horizontal stabilizers, the horizontal tail, you can see throughout there is very little elevator movement. That's the part that the pilot controls with his yoke, that makes that deflects the little flap in the end of the tailplane that goes up and down. There's a little movement there. However, the entire tailplane also moves on these airplanes, but they are not rapidly moving components. They are slower moving, and they're set to called trim. They are set at a certain point. They can be moved at any time using the trim, but the autopilot has control of it. And if you can see, the horizontal stabilizers are set at a very high angle, but you look at high nose up angle, so they tilt it in a way to push the tail down, and because when you see on the video, you can see that although the fuselage is tilted way up, but when you look at the tailplane, you're almost looking at it edge on. And also when you look at the wings, you're seeing a lot of the top of the wing, but on the tailplane you're seeing the trailing edge of it edge on. You don't see a lot of the surface there. So it's set at a very high angle. Now, and also again, doesn't seem to be any elevator movement at all. There's no deflection or movement, anything. So this is what I'm saying, the pilot airplane combination, because you don't know whether it's the airplane that did that or the pilots did that. Well, because when the engine fails like that and your nose is way up, the first thing you should do is to push the nose down. And that did not happen. In fact, you can see the airplane has the nose continue to go up as it slows and sink. And that's the opposite of what you wanted to do. So the combination of the airplane and the pilot is such that the corrective action was not immediately done. And I say immediately because the corrective action is immediate. If you don't do it immediately, then you're going to lose airspeed very rapidly, and you're going to sink very hard. So whether the pilots commanded the nose to go down, the airplane didn't listen, because you push the stick, the autopilot should also disengage. And it's conceivable if you don't touch anything, because you lose power, the airplane is not. I really wish that some of the 787 pilots can jump in and tell me that, and tell the rest of us that, what happens with the automation of the 787. Because from what I know is that there are a lot of automations in modern jets. A lot of people don't know. It's not just the autopilot. There are many automatic things. There's navigation. There's flight control. There is communication. All that. Fuel and balance. A whole lot of automating things. But traditionally, there is on these big jets, the two main things. There's the autopilot and there's the auto throttle. So I don't know how the 787 is connected, but just because you turn one off doesn't mean the other one is not engaged. So if you don't touch anything, say for example, if both the autopilot and the auto throttle are engaged and you don't touch anything to disengage the autopilot, and suddenly the engine thrust went down and the autopilot is separate from the auto throttle is separate. So autopilot is separate from the auto throttle. Then the autopilot is expecting the airplane to climb, but it doesn't know the engines are spooling down, have no power. So it will continue to trim the airplane or pull the elevator up to trying to get the airplane to climb. But there's no power. And there has been in the past that the commercial jets have went down that way. It's because the pilots didn't know that they bumped the autopilot off. I mean, they didn't know that they bumped the auto throttle off, but the autopilot kept working, and so the airplane doesn't have power to climb, but it continued to pull the nose up and hoping to climb up, but eventually it stalled. So this is a major concern, and it is obviously a concern if the pilots didn't put the nose down and actually continue to pull the nose up instead. And a lot of pilots have made that mistake in the past, but it will be even more of a concern if the airplane did not allow the pilots to put the nose down, even though they push on the stick. Again, there is very little time, but as far as engine failure like that is concerned, if you're in a nose up situation, whether you're at altitude, and sometimes even more important if you're altitude, because your margin of angle of attack and power setting is very small. Medium to lower altitude is probably not as bad in that way, but in any case, a lot of pilots say, well, they're meant for high altitude. Well, not necessarily. Anything can fail at any one time, and when you're high angle of attitude or high angle of attack, nose is up, and suddenly all the engines fail, the procedure is not just nose down, it's immediate nose down. I mean immediate, like now, like the moment that you realize that the engines are going down, your nose is high, you have to immediately put the nose down. That's it. And that did not happen as a combination of the pilot and the airplane. The whole assembly did not do that. In fact, it kept on pulling up. And luckily, because the airplane was just at the altitude that even if you continue to pull up, the airplane managed to keep the nose up all the way, in fact increasing the nose up all the way, and it only really stalled. I mean stalled. So I mean like it only lost this is something that's going to explain later, but all your pilots and aeronautical people would know that only the tailplanes stabilizers elevator combination only lost authority until the very last minute. Then the nose dropped. So basically the airplane sort of pancaked in. And this is really a difficult thing to say which is better, whether you lower the nose to keep the airplane flying a little bit, or maybe you can't because you already have the flaps down, and maybe you put the nose down, you're still not going to change much, but maybe you will reduce the sink rate a little bit, but you're going to actually quite significantly, but you will gain a lot of forward speed. So is it better to take the impact like that from the bottom where you have the gear up to absorb the impact and not have so much forward speed to plow through more buildings and kill more people? Or should you have a gentler downward speed or a faster forward speed that the impact itself, the downward impact itself is much softer, but the forward impact is much higher? So it just, in a way, it's kind of a miracle that it seems like in this particular case, because of the airspeed and the altitude achieved, and it almost seems like no matter which extreme you do, whether you did what they did or what the airplane pilots combination did, that the cap the nose up and pancake down in, because it's not that high, and so even if you pancake in, you're not going to achieve that high of a sink rate that you're going to dig a great gaping hole on the ground. And if you lower the nose, yeah, you'll reduce the sink rate and increase the forward speed. But overall, your impact, the combination of forward and downward impact, is probably just about the same. However, if you were higher, it's a completely different story. Because if you're higher and you don't put your nose down, not only that your sink rate would be extremely, basically almost free falling, and your sink rate would be frighteningly high. I mean, imaginably high when you hit the ground, and there'll be nothing left. Then if you put the nose down, then you keep flying, and you're just a big glider. So this is one fact that I think very few people mentioned. Either way, I really hope that the information would come out sooner and brought closure or little bit more closure to the victims, family of the victims, and also help the public and the airplane makers and the pilots to understand what went wrong. Because if you don't know what went wrong, how do you improve the safety? And I mean, there are a lot of other pilot 787 combinations still flying every day. And is it the training? Is it the complexity of the airplane, or is it accumulation of a lot of little mistakes through the maintenance and the manufacturing process? We don't know. We're not, at this stage, I think everybody is focused not on pointing fingers and blaming. It's trying to, two main things. Bring more closure. I mean, they're equally important. Trying to bring, more and more, closer to closure to the family of the victims, and to improve the safety of aviation as well as this particular type of airplane. And at any time where we don't have any sort of answers and data, then the risk might very well still exist, even if it is due to the maintenance or the airline operation. The airline still needs to know, exactly what they did wrong. So I really hope that that everyone is everyone involved is trying to be as transparent as possible. So I really don't think I think you can rule out the flap thing, because you can actually quite see very well the flaps are fine, they're not moving. But again, the other things that hasn't been talked about so far is that the two things is that the airplane, it has been continued to nose up even as it sank, which is the opposite of what the pilot's airplane combination should do. So something went wrong there. And then the other thing is that the tailplane setting is very high, probably almost near maximum. So it's not, the elevator didn't move much. As though, did the autopilot continue to trim the nose up because it was hoping to get the airplane to climb? Is it not talking to the auto throttle? Is auto throttle disconnected? Did somebody enter the wrong data into your computer? We don't know, but some of the little things that other very acute people and pilots spotted out was really quite amazing. They found out that yes, it looks like that they have activated the gear up, because the gear is beginning to move in the first sequence of gear up, and they also found that the ram air turbine was deployed. So these two things ruled out quite a lot of things. So anyway, I am like all of you who are anxious to await what discoveries are being made from the investigation and the two black boxes. I just like to add a little bit of what I observed and what I know about aviations and airplane. So welcome to your comments. Thanks very much. Bye.